Alright folks, next thing we're going to work on when it comes to functions is called function composition. And if you notice right here it says composition means enter one function into another. So that's kind of what we're going to do, is we're just going to enter one function into another function. So starting out with this first one, we have f of x equals 2x minus 7. G of x equals x squared plus 4. We want to find f of g of 2. Now with these, when you have the number in them, very simple, we're just going to work it from the inside out. We're going to first find out what g of 2 is. So g of 2, all it's really asking us to do is put 2 into g. So g of 2 equals, now we're just going to go right there, 2 squared plus 4. So g of 2 then is equal to 2 squared is 4 plus another 4 is 8. Now I'm going to take that value, I'm going to plug it in there. So actually what I'm finding next is going to be f of 8. So f of 8, so I'm going to plug 8 in right there for the x. So 2 times 8 minus 7. So 16 minus 7 is 9, so actually f of g of 2 is equal to 16 minus 7, which is 9. And there's our final answer. F of g of 2 equals 9. Next one we're going to do, it starts out g of f of 3, so we're just going to work inside first. F of 3. So f of 3 equals 2 times 3 minus 7. So order of operations says we should multiply and then subtract. So 6 minus 7 would be negative 1. So f of 3 equals negative 1. Now I'm going to take that negative 1 and I am going to fill it right there. So what I'm actually finding is g of negative 1. So plugging in negative 1 for g. So g of negative 1 equals negative 1 squared plus 4. Notice the parentheses. So negative 1 squared is 1 plus 4 is 5. So g of f of 3 equals 5. There. You're done. So I'm going to challenge you to go ahead and find these next couple, g of 4 and f of negative 1. Basically what it means is you're plugging 4 into g, find out what that answer is, plug it in again to g. Same type of thing here. So the answers for that, I believe, will be 404 and negative 17. Now comes the true function composition, where we actually are putting one function into another. So to start out, we have f of x equals 4x to the negative first, g of x equals 5x minus 2. Now what I'm going to do to begin with is f of x equals 4x to the negative first. I'm going to rewrite that in a way that maybe it makes a little more sense to us, where x to the negative first, we would flop that. So f of x is actually just going to be 4 over x. Alright, maybe that's something you can do as a first step in some of these problems to help yourself out. Now, this says f of g of x. So what this is saying is g of x is being put into f. Now, what I like to do when I do something like this is I like to just rewrite f of x, but without the x's. So I'm just going to rewrite f of x without the x. Instead of an x, I'm going to put an open set of parentheses, because that x is going to get filled with this value, g of x. This value is going to basically fill in wherever x would. So wherever there's an x, I'm going to fill it with the value of g of x, 5x minus 2. And there it is. That's done. 4 over 5x minus 2. That's it. Now, I do need the domain. So what can x be? What can it not be? Well, we don't have square roots. We don't have anything like that. But if you notice, we do have an x in the denominator. Okay, so we cannot have this denominator be x. So we can have all real numbers. But there's one thing that x cannot be. What number would make that denominator 0? Well, x cannot be positive 2/5. 2/5 is what would make this denominator a 0. Alright, so we can talk about that in class in a little more length, but there's our answer. 4 over 5x minus 2. We can use all real numbers except for 2/5. Now, same type of problem, g of f of x. So I am going to rewrite g, but wherever there's an x, I'm going to leave it blank. So I have 5. There's my blank. That's where x should be, but I'm going to leave it open. And I'm going to fill it with the value of f of x. So 4 over x. Now, I am going to simplify that down. The last one could not be simplified, but this one can. I can do 5 times 4. 5 times 4 is 20. So I have 20 over x minus 2. So this here is g of f of x. Now, what is the domain? What can x be? What can it not be? Well, if I take a look at where x is, it's in the denominator. It's right here. And we know that we cannot have zeros in the denominator. So for my domain, I can have any number. So I'm going to say all real numbers. But x can't be 0, because that's how I would get 0 in the denominator. So I can use any number, just not 0. So there's the answer. Okay, on this next one, f of x. So I'm putting f back into itself. So I'm going to rewrite f of x, but I'm going to leave that blank set of parentheses where x should be, and I'm going to fill it. So now I can simplify this down. 4 over x, that simplifies to x. So f of x is just x. The domain for this, since it's just x, that means it can be anything we need it to be. So the domain would be all real numbers. There's our answer. This next one, g of x. I can rewrite g of x, but where there is an x, I'm going to leave a big blank set of parentheses, and I'm going to fill it with g again. So 5x minus 2. Now I can simplify that down a little bit. I can distribute, so 25x minus 10 minus 2. So here is where the 25x came from. Here's the minus 10. Now I can combine those like terms. So g of x equals 25x minus 12. In my domain, since here's my x can be anything, there's no square roots, it's not in a denominator, so it can be all real numbers. And that's the answer. Okay, function composition does take some getting used to. So here you go, page 432, numbers 20 through 37. Best of luck to you. We'll see you in class.